Well, we're going to talk about a couple things here, mostly resin. It's going to be an overview, and I'm going to make a couple parts out of, it's the same brand of resin but different curing rates. I'm going to talk about picking out the right type of resin for your application and the benefits of different resins for different applications. So hopefully I got the camera orientation right on this thing. I'm going to turn on a TV channel and see if I can make sure that this thing is coming out right. I still have trouble flipping this thing back and forth. One of the things I did, you can see I made a rack, and this rack actually holds all these rolls. So I think I can get 15 rolls on there. So the best way for me to find out if I'm coming through all right, I'm going to stick this thing on the TV here. I stream. And the other advantage, I guess, I can look over at the TV and I can find out real quick if I'm getting the camera centered. Yeah, this rack here, I probably spent 2 days on it. It's made out of wood, and I actually cobbled it together. What I did, I'll get a better close-up here. I wanted a rack where I could actually move stuff without taking the tube off the roll or whatever. You can see here. So I can just lift these up here and I can move them up and down the rack. It seemed like it worked out really well. And to help with the center of gravity, obviously, I mean, you could get awful top heavy. This thing's almost 6 foot tall, but down at the bottom I put a tray. It's on casters so I can move it. So I put all the resin and stuff inside the tray. So far it's worked out really good. And the idea is roll the roll goods off here onto the bench. So that was one of the pieces to the puzzle that I figured out. Okay, so over here to the this bench, worked on a couple things here. One of the problems was when I do a mold, whether it was a bell crank mold or a landing gear mold, I use these big long woodworking clamps, and those work out great, but you couldn't get them in an oven because of the plastic grips and so forth. Plus they were too big once you got all the clamps on a mold. So I just took some, what is it, 1 1/4 by half, hogged out some 1/2 inch holes, put some threaded rod in it. So basically the clamp is compact enough to where you can actually cook it in an oven while it's in the mold. And then you can get a lot of them in there because of the size of the clamp. So let's see here. I'm right now over here at this little science fair oven. I got my Celsius going here, 80 degrees Celsius. I'm trying to get this up to about 120 degrees, 150. So what I'm going to do is warm this mold up. I got a couple small molds I'll probably lay up. These are for like wheels. Let me bump this up a little bit. See if I can speed this process up here a little bit. So anyway, I'm gonna get that warmed up. So you're probably wondering why would I actually want to warm the mold up? And I was talking to Sparky earlier today, and I made him a prop. It was a propeller that had like a brine ether finish on it. If you ever remember those props, it was super slick, and I was able to achieve that by actually heating the mold up. I'm on the, look over here at the TV, make sure I'm on the camera. Okay, so what a janky operation for video, right? Okay, so here's where I'm at today. Okay, so if you remember, I did a video, it's probably 2 hours plus, where I actually came out here in the shop and I sprayed PVA and I waxed these molds and I went through the whole thing. And basically PVA is necessary, but PVA room temp cure doesn't really align with the production process of this kind of stuff. So I thought back of that day I made that prop, and I made the prop on a high temp mold, and I preheated it to 120. When I brought it over here to do the layup at 120 degree mold, it might have been 150, I can't remember exactly, but it was up there. When I laid the resin in there, it became really fluid. So your viscosity drops considerably when you put heat to it. But the problem with viscosity drops when you put heat to it, you got to be careful, because then your pot life drops. So instead of having a 30-minute pot life, you can go to a 10-minute pot life, you know. So that's the problem there. So what I did, I used the HTR 250, which I've done a lot of videos, and a room temp cure 106-3 works out great. With the prop that I heated the mold on, it was a 9234. So if I read this spec sheet here, the 9234 with the 250, I'm looking at 165-minute pot life. So maybe just realistically, you know, when you say you're laying it in a 100-degree mold or 120, instead of 165 minutes, you know, maybe let's just say you have 2 hours, 120 minutes, 100 minutes is good. So that's what I'm looking for, a long pot life. Okay, so if you come down here to the heat distortion, how much heat will that take? So the HTR 250 9234, you're looking at a 350 degree heat deflection temperature. Okay, so then I'm going to go down the rabbit hole a little bit deeper here. I mentioned on the last video I did on Sparky's channel, it was Algae Composites, ALGIE Composites. It's up in Speedway, I believe, on a industrial street. He was using HTR 350 with an 8401. So the HT 8401 basically, in effect, turned that resin into a pre-preg resin, and that's what he was doing. He was laying out a sheet of carbon, wetting it out, and when he'd wet out his carbon fiber, you know, he could put it in the freezer for a month, or he could leave it on the bench all week and it would be staged. He'd actually put it on the mold, put it in the autoclave, and he was making his own tooling pre-preg. So the tooling pre-preg cost went from 185 bucks a yard back then when he made the video to probably $45 a yard or 50 or something. So it's considerably less, and it gave him the same results pretty much. Okay, so the HTR 350 with the 8401, it says the working time 40 to 60 hours. So that means when you start laying up a part, have to go to lunch, eat dinner, come back the next day, it doesn't matter. Now the downside of that is you got to put the heat to it. You got to compact it probably, you put it in a mold, but then you have to actually get some heat to it. Okay, the heat distortion of a resin like 350 and the 8401 is 450 degrees. So you're way up the chart on that. So I could see that being used on a tuned pipe. Anything above 450 in epoxy, if you want more than that, you're going to have to go to a BMI. I think it's called bismillamide resin. So that's a whole nother class, but it'll take you up to 700-800,000 degrees or something. Never experimented with it, but I've talked to people about it. So the beauty of this resin services, okay, the way this works, and a lot of people ask me what resin to use. It's not so important what resin you use. What's important is that you match the properties of the resin to your application. The resin is a brand name. So with the EPON, the resin services, and there's about 4 or 5 in California. I could go down a list and probably pull up a dozen, and they all do the same thing. What it boils down to is, do you like dealing with the people? Can you get a hold of a tech supervisor or tech person to ask questions? That's important to me. So resin services aren't paying me to do this spiel. I've used them for probably 30 years or more, and in that 30 years they've been everything I needed them to do in the wet layup. And what's really neat, if you look at these spec sheets, you can even venture out of the wet layup and almost create your own pre-preg with their system. And they also have another one that could be RTM or vacuum assisted resin transfer molding, where they actually pull the resin under vacuum into the layup. And they've got a curing agent that I've used with a -99 on the back of it with a longer pot life. So basically it's giving you the low viscosity with the longer pot life. So with all that into consideration, you can mix and match and you can formulate your own stuff here, you know, within reason. So anyway, what I was going to do is lay up this bell crank. It's got a chemical release in it. There's no PVA in it. The downside, I guess, would be if you didn't have a cured high temp mold. Obviously you can't do that, but this one, I've done it before. And the other thing is you have limitations on your surface coat. You're trying to get away from the surface coat, so when you lay this up, you're getting away from the surface coat where you can actually see the weave in there. So it's a cosmetic issue maybe. One of the things I wanted to experiment with is take high temp grill paint. You know, this stuff they sell you, auto stores, they'll sell you a paint that's good for automotive engines. It's good for 1,000 degrees or something, you know. Take that and paint that inside of your mold and then lay it up with a high temp resin. And that would give you maybe some neat parts, you know. But for stunt applications, with the way we judge the finish, it's almost imperative that the finish be outside of the mold. I know the RC guys have some beautiful stuff and the pylon racers, but you know, if you want the ink lines and the beautiful the graphics and stuff, it's probably outside the mold only. So anyway, that's where I'm at. Looks like I'm on the screen there. Looks like there's two of me. Okay, so let me get this mold out of the oven and I'm going to lay it up, see what we can get with a high temp resin in this thing. And it's probably, I don't know, it might be 100 degrees. It's not too much. It's not cooking too much. I put these styrofoam blocks to sort of keep the pins from falling through. This one's a little loose, so the styrofoam will support it, hopefully. The other thing, on a release agent here, I've used Free Coat and I've used Chemily's products, and they're all good. I've never had any problem with any of them, given that the mold is already seasoned enough. I do need to take a bushing here for the pivot. I gotta make one of those real quick. So, let's see what I do. I'm still working on this fork valve crank thing, and I've got the aluminum plate, 1/2 inch, 2024. I got to get that into the machine shop and have them machine the plate, and then I got to bring it home and buff it, and that will give me the plate to lay up the. Well, I won't lay it up. The composite shop will do the pre-preg on it. So, let me adjust this a little bit. Now, I'll tell you right now, if you comment, I can't see it because it's on the back of the phone, and I lose my comments. So let's see. It's going to take me a second here to get this thing plugged in. What I do is I take a Dremel and I put little notches. What I just did is took this oil-light bushing, see where I cut the notches in it, and basically that keys it into the actual layup. This is inserted in the mold, just like that. Let's move this out of the way for a second. So 36 inches is what this bell crank requires. 8. I got my paper on my table here. It'll be interesting laying this thing up. Cut it extra long just in case. Interesting because of this the resin. I might get to this. This is the actual carbon fiber for that landing gear. Might do that on camera too. So the bell cranks, basically what that entails is 10 grams of resin. Now, the 9234 is 25%. So instead of 33% or 24% or all these other things, this one's at 25. So I'm going to go 10 grams of resin. Get her straightened out here. 2 point. Get my tear work. Okay, so let me get 10 grams in the cup. So when you pour resin in a cup, on one of these gram scales, you have to use both eyes. You got to have one eye on the resin flow, and you got to have one eye over here on the scale. It's the thing is with a digital scale, if you can get one accurate, which I haven't found one really that's super accurate. I know they're out there, but you can see when you're creeping up on your number. When you have a triple beam, the only way to know is when the needle bounces up real quick. And if you go slow, you can see it getting lighter. I guess the trick is patience. So there we go. There's 10 grams. So it's amazing. It came out right. It came out with the 2 blows left. So the whole reason to experiment with these different resins and gel times and the heat and all these different things I'm doing is to actually get into more of a production process. Room temp is great. I still won't get away with a lot of that, but there's some parts that I want to try to speed up, and the landing gear would be one of them maybe. So now I got to get 25% of this, so 2.5. 2.5. And what helps on these cans, I actually poke a hole so I'm not dumping the full enchilada out at one time. I know this is off camera here, me pouring this resin, but I guess if you can just imagine it. So what determines the property on these parts is the actual hardener. That changes the heat deflecting temperature, a lot of different properties of your resin, the hardener. So we got 10 grams of 9234, 250. This has got more of an amber look to it. And the 9234, right off the bat, it comes into like a maple syrup look. That's about what you're looking at right there. That's your viscosity. The 9234 and the 250 will room temp cure. The 350 and 8401, that's the 40 to 60 hour thing. So this is obviously right off the bat, you can tell it's a thicker resin. So the spec sheet on the 250 and the 9234 Unfilled, tough, strong resin system with good heat distortion, which would be 350, chemical resistance, and excellent adhesive quality. So the chemical resistance, it'd be interesting to do a nitro test. I might take this bell crank and then dunk it in a jug of fuel or some fuel, see what happens. See if we can come up with a resin that's maybe fuel resistant for tanks. We've already come up with it. I think it'd be nice to have a backup, I guess. Yeah, I was talking to Sparky this morning. I said, you know what? I said, you're back on the balsa wood airplanes. I said, I'll throw a video in there on this, on the epoxy. I'll keep them bored for you. We'll give them both, I guess. Some epoxy theory, layups, and also some sanding. So a high temp mold, basically it's a bell crank casting just like all the rest, but it's got a high temp resin. Don't ask me what this is, it's been so long. I think HAC 560, it's a casting resin that's high temp. That'll go up to 350, 400, and that's what it might be. And then same old thing, the pins, the bushing and everything, same setup. These little bell cranks are fun to, if you get small quantities of something and you want to try different casting resins, it's really nice to have this size because you can make a couple castings out of their sample. They'll send you, places will send you samples of stuff. And you can go through there and try it out. It's a perfect size for that. Alright, this is my 3-footer. I got my chop here. I always need a little chop. One of the things I'm probably going to do here is get a heat gun over here. I'm going to put some heat on this. And that way I can sort of pop the bubbles as I go. This is a monocoque gun. We'll lay this up like we've always done. Start out with a little chop. The other thing will be interesting. Once I get this clamped up, we'll find out what kind of cure schedule it's going to take to actually demold this. Let me move this camera in a little bit and I'll give you guys a better look at what I'm doing. See if I can put this camera right on top of the tray here. I don't think I can get it that close. There we go. Sort of shows you what's going on here. So with this chemical release, there's no PVA, and a good free coat 700 NC. It'll beat up on you. You're going to look at this and you're going to see the resin beat up. See how much of this I can pack down in there. And it wets out pretty easily, just like the 250 with the 106.3. Traditionally, now these bell cranks I'd lay up in the past. It'd be a epon 815, and the curing agent would be Resin Services HT 386. And that's what all the bell cranks that I've either given away or sold, that's what they're made out of. Okay, so this here, what I'm doing with this 250 and this 9234, this is just an experiment. It has nothing to do with the what I've made in the past. So don't get confused if you see you see me do this. And all I'm trying to do is come up with an experiment. Get these pins in there. These pins have got release agent on them. Being a high temp mold, these holes that hold these pins aren't tight anymore for some reason. Don't ask me why. So they sort of sprung out on me. The other thing that happens, I believe, when you lay one of these up high temp, all the air cooks out of it. I don't know if you guys have ever watched them do these epoxy tabletops, where they pour this resin over the tabletop. One of the things they'll do towards the end, once they do the pour, they'll take a propane torch and they'll fan it over the top. By fanning the torch over the top, they actually pop all the air bubbles. Now, as you're watching this, you're probably thinking, is it getting wet? I mean, is he actually able to lay this up and make sure that the carbon is saturated? As you probably noticed, I've got a lot of extra in here. I mean, there's way too much resin. And that's by design. I did that on purpose, and I'll show you towards the end of the layup how to compensate for that and draw that back out of the carbon. So since I'm not actually vacuum bagging to debulk this, I'm doing it by hand with paper towel. So the first lap around these pins, as you can see, is a 360. So I got one lap, 360 around the pins. Let's put a little heat on it. So all the air bubbles that were mixed in here basically is gone. So this resin, it's got a slimy feel to it. It's got a different feel because of this curing agent. And believe it or not, it might be just a little bit thicker, but it's got a superior wet out. When you put that hot air gun on it, it really flows. So as you see, I'm going to the outside of the pin. The second lap is the outside of the pin. And I'm starting on my third lap right here. My final lap, my third lap, is actually a 360 around the pin. So I do the 360 initially, and then from there an outside, and then I finish up with the wrap, 360 around the pin. I see a little bit of styrofoam in there. Probably the next experiment I'd actually do with this part was to pre-wet the carbon outside of the mold. That might be a viable thing. Pin fell through there a little bit. Now to get these pins to stick in that mold, probably what I should do is put just a drop of CA down in there, give it a little friction, lap that pin back in there. I should have done that before this, but so this is wetting out really nice. Now the 9234 is an actual curing agent you can use in a casting, I believe. You'll notice with the resin services, they'll mix and match different hardeners and resins to give you different properties. .1063 I think gets you up around 300 degrees probably. 9234 curing agent, I believe it's 350. So it'll make a higher temp tool or part. I think I got the wrong camera angle. Get this camera angle just a little bit over here where you can see it better. Now, at this stage, what I try to do is go back and fill in with a little chop. I'll see areas that, you know, are maybe a little lacking, just like in the corners. And I'll take a little chop in there. Once you make a few of these things, you sort of you get a feel for what it's going to take to fill it. Now you can use a heat gun on the 1063 or the EPON 815 and HT 386 and all these different things, but the beauty of this 9234, it gives you the open time. you're able to actually spend more time packing the mold. Which in some ways, you know, it helps. In some ways it might not, because the bell crank's one of the things that the resin, when it started to thicken up a little bit, it allowed me to pack the mold a little tighter. So this is an important part right here. So as you can see, I'm smashing this carbon down, and you can see the resin come out. And as the resin starts to bubble out, you blot it up. Get that pin stuck through there. After a few cure cycles, I'm sure there'll be some resin stuck in that hole where it'll allow that pin to stay up. So I'm getting a lot of bleed out of this resin here. It's becoming pretty obvious real quick that there's a lot of extra. So as soon as you compact it, it's like right here, see how it's springing out of the mold? Smash it down in there, sop up all that extra resin. See it come out there. And then once you get the excess resin, it starts to get stickier, and it doesn't want to float around in there. It'll hold its shape in the mold a little bit better. So coming up here, probably in the next week or two, I'm going to be doing some experimenting with resin that has the open time of 40 to 60 hours. So this is packing down in there really nice. The other thing you can do, take the paper towel away from the mix, and you put your fingers over it like that. And if there's air bubbles, it feels like little Rice Krispies popping. You can smash it with your fingers like that, and you get the old Rice Krispie effect, which I'm not getting that right now. So 9234 with the 250 is leaving me a pretty slick, tight layup. So Brent called me, the Brent from Kansas, I believe. We were talking about resins, and I told him the 815, and that's probably your best choice. Low viscosity, you can use it on layups, wheel pants and stuff, fiberglass wing center sections. For this 9234 to really get good, it's going to take the heat. So don't think you need to jump on the bandwagon for a bell crank with 9234 and 250. There's more than one way of doing it. I'm using this as an experiment. And Sparky knows what I'm talking about because he's got the prop. I made a prop with this curing agent and resin. So basically what I'm trying to do right here is duplicate the finish and the curing properties on that prop. And it's been, probably in the early 2000s is when I made that prop. And I can't remember the whole scenario. So what I'm trying to do is duplicate what I had back then. Sparky knows what it looks like because he's got the prop. So this resin's starting to thick up a little bit. You can see it in the cup. It's curing agent starting to react. You know, they always talk about pot life. I don't know if your pot life is cooler than mine, but you know, at a 77-degree temp, I always experienced less of a pot life than what they were speccing it out at. And I think what they're talking about, pot life as far as before it gets hard. And there's a pot life of when you can't use it anymore, and then there's a pot life where it becomes harder to wet out. The viscosity goes up, and that's what I look at. It's not the complete pot life, but I'm looking at the pot life that I can actually get a good wet out with it. And right now it's tough to get a good wet out because it's getting thicker on me. So anybody watching this in real time, now that's a 10-gram mass, okay? So we're not talking about a lot of resin, 10 grams. So at this rate, now you can see from the screwdriver before to this, there's a lot of difference with viscosity. So I'd still say you've got a really short time for a short window for a really good wet out. So I'll go through here and get the Rice Krispies out, blot up a little bit more resin. You always get some Rice Krispies crackers when you put the chop in there. If you introduce a little bit more chop, make sure you go back for some more compaction. Yeah, the 40 or 60 hours, 8401 curing agent and the 350. Heck, I'll be able to go sit in the easy chair half the day, take a break. And I'm sort of excited to try it for certain things. Like I said, if you get on Algae Composites, I think it's Algae Composites, it's ALGIE. It's on a YouTube channel. Search it. And it's one of these videos like this, okay? It's not a high production thing. It's not fancy. It's a guy with a camera in his shop. And he wets out a big old sheet of carbon. He wets it out on plastic. And he's making his own pre-preg. So there's another video of him where he's actually laying up a really complex conical shape. I don't know what it is, but it's really complicated. It's worth watching. It's how he vacuum bags it, or how he forms the bag around the part. He's using standard pre-preg on that. The beauty of pre-preg is it's all stuck together, so when you start actually piecing it in, you can place it perfectly in the mold. And that's the beauty of pre-preg. Okay, so now I need to go over there and get my plate. It's in the oven. I'll put a little bit more resin on there and we'll tighten this bad boy up and stick it back in the oven. So, my plate's nice and warm. I didn't get the mold as warm as I wanted it. It's just I pulled it out a little bit too soon. So let's put a little bit of resin on top here. I feel that this will stay on the top, it won't soak in. And my aluminum plate's got the release on it. Find my holes. Now, I'll tell you, this is sort of like a after the fact here, come up with these. I've seen molds out of metal. Trion's got one, and he's got it to where the clamp is built into the mold. He's got the screws and everything. And I've seen a lot of molds like that, and they're really great. But the thing is, if that resin wicks out into the threads, you're going to have trouble, and I've seen it happen. So as long as you can isolate the resin from migrating into the threads, you'll be all right. So I made these by myself here at the shop. I just took them over to the drill press, these little clamps. After making a couple of them, I thought to myself, you know what? If I have to make a whole bunch of these, I'm going to take them into the machine shop. You find a machine shop with an apprentice in there with a Bridgeport, and give them little specs on these things. It'd be a good project for somebody learning the Bridgeport, so they could get the readout dialed in and make these little clamps really quick. Obviously, you want the clamp close to the mold. You don't want to have to over tighten too much, because there's too much threaded rod here. And just like anything else, I guess, tighten it up. You want to make sure that, you know, you get this thing tightened even. It's leaning this way. So normally a deep socket might work good, but I tell you what, this is the quickest thing I could grab. So that's what we're going to do. This is a metric one, by the way. Yeah. You know, we laugh about that. So get me the metric crescent wrench. I'll be danged if they didn't put a scale on one of these that was metric. This one's got the inches. I don't know if they put that on there as a joke or what. We'll laugh about it. And this is a half-inch all thread. I went to a metal supermarkets. It was a week or two ago, and they got a rack up front with all the little stuff, you know, cut-offs, scrap, and they had these bars. They were already cut. It worked out perfect. So anyway, I bought, I don't know, about 18 or 20 of them. They were this length. And I drilled some holes. I got some all thread, which is half-inch here. This temp for this other landing gear, this carbon gear over here, it's got the hump in it. That's a high temp mold. I can't remember what I post cured it at. It's been post cured. That's probably about as good as it's going to get here, clamping it. You can get some pretty good force on it. To see what's neat about this whole thing, you don't have the big handles in the bar. It's pretty compact. You know, you're able to fit it in an oven, stack them up. So I'm gonna plug my oven back in. I plug my heat gun in the cord. Let's see, take a walk over here. I got this thing set at 90 Celsius. And let's see. Let's go. I got it right up here. I got my cheat sheet. 97 gives me 150. Now, these are real temperatures right here, basically on this lab oven. That's after about an hour. That's what it is. Now 180 Celsius probably doesn't transfer to 300, but that's what this junky old oven does after you turn it on. So that's sort of like the real deal. Okay, I got some nice little toasty wheel pan, or not wheel, but wheel molds. And I might whip up a little bit of extra resin and lay up a couple of these carbon fiber wheels. And I'll show you what that entails now that I got your undivided attention here. Oh, Lord. Okay, so here's what I pulled out of the oven. These little cubes, or little wheels. Okay, so I'll explain how I got this far. So when I was working at JT's, I got a lot of scrap, and it was just to experiment with and to play around and learn. And so what I did is I came up with a little mold with these wheel molds. So the story behind these things, excuse me, John Jordan and I were talking on the phone, and he was making these wheels out of aluminum. So he'd take aluminum discs like this and he'd actually machine it, and then he put the tire on it. So I came up with this, okay. So the process here was to make a carbon fiber wheel. The tires are another story. That's a different thing. These wheels are set up almost for an O-ring, okay, because when these things come together, it's very narrow. So I'm thinking of a silicone O-ring or something with enough cushion to where you don't get the rattle and you still get the cushion. I don't know, there's a lot of variables. So in order to come up with this whole deal, this is your machined puck, I'll call it the wheel mold. And I got some PVC and I cut a groove in there. And then I had to split the PVC, see where it opens up? So that way you can release it. So once you mold this casting, you can pop this PVC off. So it fits on there, it keys on that notch, and then from that notch you make this casting. And then of course the casting pops off. Okay, now you got aluminum mold and you got your casting. So technically, if you have an angle to where it's vertical, you probably should go with sheet wax in there or whatever. But since I had a taper there, basically this was cast directly on that aluminum plate. So the idea is when you lay up your carbon fiber fabric on this and you sandwich it together, you clamp it, and now you've got that shape. And it's sort of like the, well, what do I want to say, the carbon fiber bell crank, to where that, when you made the two pieces, you had an offset like that on that plate, and that's what created your fork. So think of this as a fork. So you got to make two of these, a right and a left, not a right and a left wheel, but right and left for one wheel. And basically these two carbon pieces come off of this mold, and you flip them over, and these two discs come together in the center, and where that joggle is what forms the gap. Okay, so that's where your wheel goes. That's where your O-ring would go, or your wheel. So the width of your wheel is dictated by how steep that taper is, how much offset between here and there. And that's how you can adjust the thickness. Now, if you wanted to adjust the thickness of your tire, the width of the tire, you could actually add more carbon in the center, which would basically build it up, or you could put a core in there, which would actually take your fork and move it apart. So that's all adjustable. So this is just a science fair project here. So this was a way of coming up with a system to make wheels not super fast, but probably faster than the Chinese lathe. Okay, if you go to a machine shop and you want them to machine these wheels out of aluminum, they could probably drop one wheel out of a good machine in probably a minute or two. I mean, it would be super fast. But this was just a fun project, you know, to try it out. So what I did, I grabbed some scrap. Let's see what I got here. Some harness satin twill here, or whatever you call it, 2x2. And I was just going to wet out some discs here, and then put them in these molds, clamp them together. And then once I clamp them together, they go back in the oven. So let's just say, I don't know, 2 layers on each side. So I'll go cut this into strips. 2. So let's cut this up a little bit. We're going to go with the TLAR. That looks about right. Carbon over here. So here we got enough to do this right here. So we'll wet this out. Another thing you can do, it's sort of neat, especially with fabric like this, you can maintain the orientation of the fabric. Another thing you can do, you can skew it like that, which tightens it up. You know, if you want a tighter weave, or you know, I know people spend a lot of time actually orientating the weave and the mold, which is great. For stuff like this, I don't really see where it'd matter too much. So let's go with the same stuff we had before, we'll go with the 250 and 9234. Now that I explain this a little bit, let me take these over there, and I'm going to keep them toasty in my oven. And I've already got release on them. So let me put these back in my oven, and I'm going to wet these out. It's amazing when you pull them little puppies out how quick they cool off. So I'm going to guess, let's just go with 20 grams. Let's go with 20 grams of resin. Let me get the cup on there. I think it's 2.8. So basically what I do is I zero it out with a cup, and it's let's see, 2.8, and I'll go 20 grams of resin, so I'll move this to 20. It's going to take quite a bit at first. Ease up on it. Once you do it enough, you can sort of visually tell by the volume how close you're getting to your number if you make the same stuff over and over again. Okay, so there's 20 grams of resin. So we're mixing at 25%, so that'd be 2.5 per 10 grams. So we got 20 grams, it would be 5 grams. Okay, so it'd be 1, 2, 3, 4, 5. There's our 5 grams. Now what did I do with my curing agent? Now, if you ever overshoot the curing agent, you could pour it off the top. So the curing agent doesn't actually go into the resin usually. It'll sit on top, and you're able to skim a little bit off the top if you overshoot it. And I've done that before. So we're probably over maybe a half gram. Not even over a half gram, couple tenths. And I consider a few tenths being within tolerance for my wheels. Get this thing over here on the gimbal. One of the things a lot of guys do, instead of wetting that over cardboard, they wet out over plastic, and that's probably a good idea. I got some plastic over there on the rack, but I just haven't actually cut any off. So the oven's set at 150 thereabout. So one of the things that help in composite work, when you actually heat cure a part, it's like putting it over in the oven, right? I put my bell crank in there at 150. So if you put it in at 150 and you let it soak a while, basically what'll happen, it gives the resin a chance to lower itself in viscosity. If you look at a bell graph or whatever, usually the resin gets thick, and then you put it to some heat and the resin will dip down a little bit in viscosity. As it starts to come down, and then it starts to well, not exotherm, but cure, then it'll come back up. But that little dip and that lowering of viscosity and letting it soak at that lower temp where the viscosity gets really low, or as low as the resin will allow, it allows the air and a better wet out. And it's the same thing with pre-preg. If you take a pre-preg piece and you throw it in the oven and let's say it cures at 300, and you throw it in the oven at 300, basically it goes so fast to the cure, it doesn't allow everything to flow and saturate. So they've got stuff out, it's called a Toray snap cure. Okay, that stuff is designed to cure within, I don't know, 2 or 3 minutes. But normal resin, like what I'm mixing here, or a pre-preg, a normal pre-preg, I believe, it benefits for that soak. Now, you can get on Google and you can search Toray Snap Cure. And it's really an amazing product. It's almost like thermoforming. And maybe there's properties in that resin that are that. So the way that works is, let's just say there's a video. You have a male and female mold. This would be the Toray Snap Cure right here. You would actually form that in the mold, okay, just like a normal pre-preg. And this would be a preheated mold, or the machine would preheat it somehow. You put the mold in a hydraulic press. It comes down under extreme pressure and heat. And you can see the resin pull out of the mold within about 30 seconds. After 2 minutes, the hydraulics come off, it comes out, and you pop the part out. It's probably a 5-minute cycle for a carbon part. It's unbelievable. So the stuff that's out there, if you really dig for it, it's really fascinating. But the problem is, you see all this fascinating stuff, and it's like, well, it's all fine and dandy, but how do you translate it to the hobby, right? And what I'm trying to do on these videos is translate some of this stuff that's out there, there's unlimited amount, translate it into what could be used for our hobby. And you got to be careful too. I mean, as far as weight, a lot of this stuff, it sounds good, and you think of the whole airplane being out of carbon, and it doesn't work out like that. It does in some respects, but you got to be really careful. The reason I've got all that glass cloth over there, the rolls you saw over there earlier, if you look at the carbon or the composite stunners, or these I think it's F3A, the guys that fly RC pattern, and look at the construction. It's glass, wood glass, or glass, foam glass. They probably do it for a couple reasons. One reason being the carbon causes radio interference. The second reason, it's cheaper to go with glass, and probably the third reason is you can't get the carbon in 3/4 ounce of square yard glass, or even an ounce. And let's say you did have it, the cost would be off the chart, and it wouldn't be worth it. So that's why, you know, they're back to this, the fiberglass. I mean, but if you look at the technique some of these guys have with building these airplanes, it's phenomenal. So by wetting it, it probably just allows me to lower the viscosity a little bit for a wet out. The other neat thing making these parts, it'll be a fun experiment to see how fuel proof they are. Supposedly this 9234 brings up a chemical resistance that the others don't. And Sparky's building tanks with a Teta, and along with that is the Epon 826, 862. Don't quote me, I forget what it is. It's 8 something. So this stuff, it's wetting out super easy. And I'm not really worried about air bubbles in this too much. I mean, this will still give us a good part. Now, one of the things that really surprised me when I made that prop that Sparky has now in his shop, I guess, but when I made it, it was amazing at how void free that was. See, that went all the way through. Perfect. And then, of course, the heat gun allows it to flow better. And then also, when I put it in that mold, I'm trying to remember where I got some C-clamps laying around where I can actually put them in the oven. I don't know if I got any in here or they're in the tool trailer. The other thing is, you find out real quick when you start really clamping this stuff between these molds, how much squeeze out you get. So that's pretty much 100% saturation there. I think the next thing, I might do it on the camera. Heck, it's on, this is on Stunt Hangar, so I might just do it on his channel and fill up his bandwidth. I might lay up a carbon gear out of this stuff while I'm on a roll. Okay, so a normal layup, that's really wet. With this whole deal here, all I'm hoping for is the actual squeeze out to get rid of the excess. So let me go over there and get my little hockey pucks and clamp those little puppies up. So these are nice and toasty. So that was the way I was laying up that prop, those props. I preheat that mold. By doing so, it allowed this stuff to really wet out nice inside that mold. Now, basically this little knob here has got to work its way through the weave, just like that, into the mold. And then of course I'll trim that before, I'll trim it off pretty close before I clamp it. that right through there. The neat thing about this carbon stuff and these molds, if you can dream up a shape, you can make it. You know, it's just a matter of actually coming up with the properties with the mold. With the right temperature or whatever you want to do. I can hear the squeeze out a little bit. I probably could have gooped it up a little bit more, put a little bit more resin in there. I think they're going to come out just fine though. Somewhere I've got a cruddy pair of scissors I use. Here they are. For some reason these things have lasted forever. Okay, let's trim these down. So let's say I was going to do an experiment after the fact, right? I'm going to see if it's fuel proof. Save all that, you know, all this stuff laying here. And, you know, see what kind of chemical resistance it really does have. That way you don't have to subject your part you just made to that. So I try to always branch off into a second science fair project. If that would cure hard, you definitely wouldn't want to step on it. So I'm not sure if I've got clamps for this or not. I'm just going to use the old woodworking clamps. And basically, I'll probably just take these here. Well, I sure would like to get them in a better clamp though. Maybe these things will take 150, I don't know. I like to cook them in the oven. I like to put the full cure on these things in the mold. Let's say I was making a bunch of these things. I'd probably have to have something like a hydraulic press or a designated clamp for these things. Probably machine these tops to where they come out with ears on them, and you have 3 bolts that go around it. Yeah, it'll be interesting to see how these come out. I'll put them in the warming box. I'll find my clamps for the another version where I actually put them in the oven. You know, when I do these videos, I turn on the camera and sort of wing it. I know it drives some people nuts. Unedited. I'll tell you what though, you get a screw up, it's right in front of your face. That looks pretty good. I'm getting a lot of ooze out on it. So that looks like a good deal. Let that cure up. And then I can always take the clamps off probably, oh, I don't know, maybe 8 hours or so, 10 hours. Once it goes into the B stage, I could throw it in the oven and post cure it. we'll see. It'll be interesting. See what I can get away with. So, really good wet out. And those two little wheels, it took basically 15 grand or so. But that's the process there from the basic concept with the aluminum puck and the wheel. You know the old thing, they usually say don't reinvent the wheel. And I'll tell you what, right there is a perfect example. Right, reinventing the wheel. Let's get rid of this. Get rid of this stuff. Yeah, old Cheeto, an old shop cat, he's out. He's being a lion today. He's out in the jungle. The last tone, clean up the film. I did a little experiment on this glass about a week or two ago. We were always talking about painting in the mold. The deal is when you paint in the mold, the masking tape or your mask has to actually stick to the mold. Now there's some release agents that you're not going to get anything to stick to it, tape or anything. And that's one of the ways they check to see how much release agent they've got in the mold. They'll actually see if it'll hold a piece of tape. So basically that eliminates that mold release when you can't get the tape to stick to it. Now if you take wax like you wax a mold with, you know, with PVA, and you wax this glass, well then when you do that, the tape will stick to it. But I did a test sample where I tried to get the acrylic lacquer to peel off the glass and have the epoxy stick to it. And the problem was with the wax I was using, the mold sealer wax on the glass, it didn't allow the lacquer to come off the glass once the fiberglass was on it. So I did a test sample here, and I used free coat on the glass. Free coat 700 NC. Okay, one layer, rubbed it really good multiple times, you know, just made sure it was wet out, and then buffed it off. And you could tell when you ran your finger over it, it's like, yeah, you could tell it was slick. But the masking tape would actually stick to the glass with the free coat on it, so that would allow you to mask in the mold. And this came off the glass, so there was free coat 700 NC on the glass. This was lacquer out of a rattle can. I sprayed that down, okay, and then I just took West Systems and a couple pieces of fiberglass scrap and let that cure. And then the next day I came out with a razor blade and I sort of peeled up the paint, and I got under the glass, and it came off. So the 700 NC free coat allowed me a release off the glass where the epoxy stayed to the lacquer, and lacquer came off the glass. So these guys that are actually painting in the mold, they're not using lacquer, they're using the 2K, and it's usually automotive stuff, right? So the automotive stuff is catalyzed, and highly atomized guns and highly, what do I want to say, it's highly delicate mask, like a frisket or masking film, and they're able to get really good results. Now, back to what I said earlier, the it doesn't really apply, okay, so for a stunt plane. But let's just say you wanted to make landing gear or some part, you wanted a nice color to it or something that might be beneficial, but for our stuff, for control line stunners, I don't really see where it'd be beneficial. So that's my thought. But anyway, at least I figured it out. Free coat will release lacquer and it'll allow you to tape it. So some of these other stuff, things that are really super slick, you can't even get tape to stick to it. So here's an old landing gear mold. This was ancient. This was in the tune pipe days. So this mold was sitting there for a while. It's got the surface coat in it. Instead of wasting the surface coat, I think what I'm going to do is throw some carbon in it. And I promised some people a mold. I promised some people some landing gears. And what I'm trying to do here is tool this whole place up so I can do some composite work. And I'm working to that goal. So instead of wasting all the work I've got in this, and I think I'm going to lay it up. Now, Sparky asked me a few times, he said, now that my surface coat has been in this mold for a day or two, will my layup stick to the surface coat? And my answer is yes. Ideally, the surface coat should be like a B stage, getting the dust out of it, to where the surface coat is just barely tacky, but you can't really deform it. That way you know you're getting 100% bond. But the way this is, the surface coat is so thin and it's basically non-structural. So basically, as long as it's stick as well as a paint would, you're fine. You just don't want this free coat, or you don't want the surface coat to be peeling off your landing gear. And you probably watched me clean this out with acetone, okay? My brush. I had some brushes from a while back that I would put the surface coat down, just like I did here a week or two ago. And then I'd go to actually lay up the gear, and I'd start putting resin in there like this, and my resin was beating up. It's like, wow, it's almost like there was a release on top of the surface coat. And it never used to happen before until I got these brushes. I bought them online, I think. And there's no quality control on these things. You know, who knows where they've been. So anyway, I traced it. I knew it was either the cup, okay, because I had, you know, new cups like this. And then I also had new brushes. So I traced it to the brush, and that's why I clean them out with acetone. So I solved that problem. We'll see what happens. But, you know, just even though it's been here a couple weeks or whatever, you're still going to get resin to stick to that. So now the quick question is, what am I going to make this out of? I think it's going to be the same thing, the HTR 250 and the 9234. Let me get a bigger cup. One of the rules of thumb, for the guys that are watching that haven't messed with this or seen it, is you weigh the carbon and you try to match the same amount of resin. And that way you start out with 50-50, or you try to hit the 50-50, And I always have a little extra. So let's just say, I'll show you what I mean. Let's see, like this carbon weighs what? Let's see what we got here. We'll mix a little bit more resin than this weighs, maybe by 15% or so. Let's see, carbon weighs. Don't weigh much. So right now we're looking at 15 grams of carbon right here. So I'm probably going to add more carbon. That's just starting in the mold, so I'm probably going to have to add more. So I'm going to be safe. Let's see, instead of 15, why don't I make 40 grams of resin? And that way I'm assured of getting enough. So my cup is a grand total of, let's see. I'll tell you what, when you start messing with this stuff, when you start flip-flopping around with different curing agents and cups, and it's easy to get screwed up. So right now we're looking at 7.5 on a cup. So I'm going to put 40 grams of resin. 250. Try to ease up on it. If I overshoot it and I get a funny number, then I got to get my calculator out. So you saw the needle a little low. One drop brought it up to where it needs to be. Okay, so we got 40 grams of resin in there. Okay, so it's 25%, 2.5, would be 10 grams of curing agent. 9234, so we'll just move this 10 grams. Alrighty. I'm going to get lazy and forget about the cardboard. I'm going to lay this right up on the glass. I'll just have to clean it again. Yeah, the 9234 and the 250, it basically gives you a slimier resin. I don't know how to describe it, but it's a different feel. Yeah, once I get these carbon fiber wheels figured out, the hard part is going to be getting the tires. I'd like to buy the tires already made in a square O-ring or something. Would be, if I could get the right diameter of silicone O-ring that's square, and I mean get a bunch of them, like a case of them, a couple thousand in a case, and get them relatively cheap. That would be the way to do it. All just to save a couple grams. like like Bob Hunt said, is it worth it? uh, I'm talking to Paul Walker about carbon fiber and stuff. He tells me, first thing he said is, you're not going to like what I'm getting ready to tell you. Basically all this stuff, you know, like this gear right here. I didn't come up with this gear, with this hump and everything. Basically somebody sent me a drawing, and right before I got out of it, somebody sent me a drawing of a gear. I think it was for Fitzgerald's airplane or something. It was all custom carbon fiber for the tune pipe. So the people out there flying this stuff, basically they're telling me what they want. They're telling me the geometry of what they require, and all I'm doing is going back after the fact and figuring out how to make it, you know, how to tool it up, you know, how it's going to be made. But the actual shape of this stuff, it's not mine. I'm just going by what people want. And if you come up with something you want, that you think you're going to want it, which is great, but if you're ever thinking of selling anything, you better not do what you want. You better be doing what somebody else wants. You learn that the hard way. So you're beating somebody else's drum there when you sell it. And who cares what it looks like? And if they like it and they're paying you money for it, and then you're good to go. So I got my clean brush. I got my resin full of bubbles here, and we're going to actually wet this out. Now, I guess I could take the hot air gun and I could fan it over this cut, but I'm going to do something a little different. Let me get my monocoque gun plugged back in. Well, it already is plugged in. What am I talking about? I thought my oven was on. It's plugged in here. So let me wet this out real quick. So what I'm going to do, I'm going to come right down here like this. Which, as you can see, okay, it's full of bubbles, which is fine. We're going to put a little heat on it. And you can't tell from the camera, but you can see the bubbles popping. So, I just got rid of the bubbles, 90% of them. Okay, let's wet her out. You gotta be careful. I blew up a piece of glass. I was doing some kind of Mickey Mouse copper pipe. It wasn't a control horn. I was doing it on the glass. And I had my propane torch out. And about the time that brazing rod started to melt, and I thought, man, this ain't good, right too close to the glass. And sure enough, the glass cracked and shot across the bench. It's like, oh my gosh. So I ended up getting another piece. Cheeto outside.
I thought you were talking. I don't know. I just got home.
Oh, yeah, I'm on TV.
Really?
Yeah.
I got bad news.
What is it?
Kroger didn't have Land Shark,
Oh my gosh. Okay.
and I couldn't take, a car full of groceries to somewhere
No,
else.
you're good.
You'll have to. There's a few Corona in there, but
Okay. So once you get this carbon wet out, I work it from the center out. And you can tell by rolling it like this, you can feel the dry spots. And you just keep working it. Now I think there was eight toe in here, if I remember right, 8 or 9. It's been a week or so. I cut this, I don't know, a week ago. I got sidetracked on another, something I had to do. I do that a lot. I'll get stuff going and halfway through move on to something else. It was a plumbing issue, so it wasn't anything that could wait. And try to keep it as straight as you can, you know. It doesn't have to be perfect, you know. You're going to see little wavies here and there, but it's all right. In a way, I mean, doing it on the glass here, it's beneficial to the point where, you know, you don't have the cardboard sucking up your extra resin, your cardboard paper, whatever. All right, let's get this puppy in there. I like to put a really thin brushed in film of resin. Helps it slide, and I think it helps the air bubbles escape a little bit when you compress it. You know, one of the neat things I did, it was years ago, it was in the 90s, I believe, but there was an AMP school out at Purdue University / Vincennes. It was a combination of the two schools. It was at the airport. And I took the class. I think the AMP, it was probably like a class for a senior. It was an elective class for AMP mechanics, and it was over composite structures. So I believe, if I remember right, I think the class was $350, and I can't remember if they had an autoclave or if it was an oven or what, but they never turned it on. But the guy teaching the course, he was from Scaled Composites. You know, the old Burt Rutan scale. And he worked there for quite a few years, and he moved back here, so he thought he'd teach some courses. And believe it or not, when I went into class, I was expecting more people. Well, there's 4 of us. And you got to remember, AMP class, or you know, there's only so many people. And then when you take the composite elective courses, you know, there's even less. But it's very interesting. And one of the neat things about taking the course, I sort of found out by accident. But I took my school ID, which basically they gave me an official ID because I was enrolled in that class through Purdue. And I went into the bookstore, and I was able to buy software at cost. So basically they were selling, no matter what kind of software you wanted, at $5 a disc. And back then it was C++, and you know, they had all the anything you'd want, basically. So long story short, I was able to pay for my class just by purchasing some software, and that was a good deal. So I don't know if you're interested in this type of stuff, find some place that's doing composites and work part-time, or actually take courses, you know. Ed Wask is involved in a fair, I think it's going on, aviation um, for kids, where I believe they're covering a lot of different aspects of careers in aviation. And I'm sure composites fits right in there somewhere. So just like the other gears I make, you know, I come in here and I actually trim the ends, and I'll take this right here and I'll flare it out so I don't get any hard points, and I'll lay that in there like this, and I'll add a little bit more. Since this here is narrow and it flares out, I need to actually add more toe up here. So I like to utilize the cutoffs. And I'll do the same with this piece here. Stretch it out. And what I'm doing by flaring it, I'm getting rid of the hard edge on it, tapering it out. Get it pretty close, and you could work it around in the mold a little. Like that. Always keep some paper towel handy. That's your best friend. And, you know, depending on your geometry, you could probably put chop in certain places, you know. So sometimes, you know, with these landing gear, you can actually post cure them a little bit, you know. With this one, I think the post cure will probably go up around 350. I believe if the tune pipe is going through here, I want to make sure that it's going to withstand the heat. I think when I get this thing done, I'll just find somebody that's flying a pipe and give it to them. This resin with the 9234 loves heat. It likes the heat gun, the oven. I'm not talking huge amounts, but you know, 250, 275. It likes a lot of heat. And it still gives you a fairly quick cure. Put some heat on that. Now, ideally you want to keep a record of what you put in these molds, and I should be doing it now, but I'm doing it by looking at it. I'm looking at this mold, and I know from experience the way this is set up that I want enough toe to actually be level with the top of this mold. I've done enough of them before to know that's what I need. But it'd be nice to have a recipe, you know, so when you actually start laying it up, you don't have to keep cutting. You cut it all at once. I only made a few of these, I think. There's probably, out of this mold, there's probably only 4 or 5 of these gears out there. And I'm making this fairly wet. And I think I'm going to do a little bit of chop right up in here. Looks like there's right there at the bend, it could use a little bit. The other thing you can do, if you're so inclined, it's like right in here. Let's just say that, well, we can do it. Heck, this is sort of an experiment anyway. I could come in here like this with some cloth. I'll make this piece up, come in here. Now, get it pretty close. And then I can fill that top with some weave. Now I've done that out here at the ends, and I'll probably do it with this one, where I'll take the plates, underneath the plates, before I close the mold at the end, I'll put a weave in there that gives you a little bit of resistance for splitting, so you don't have all unidirectional going one way. Now let's see what I do with my little scraper knife. Guess I'll use this. I'm not worried about it falling apart. It's all going to be closed up. Okay, so the beauty of putting some weave right there might be, sort of holds everything tight. Get rid of the washout. That fills it up nice. I like the way that looks. Now, right now I'm getting rid of my Rice Krispies. Now the last thing I do, and I think it's pretty important, before I close the mold, I like to take a dull screwdriver, which is this one here, and I like to go down the edge here. Now remember, I've got surface coat in here and I got PVA everywhere else. So I got to be careful not to disturb that. This is super rounded and dull. So I like to pull the carbon away from the closing surface of the mold right here. And basically when the mold closes, the edges of the top mold go in that groove and condenses everything into a pile. Otherwise, if you don't pull it away from the parting seam there, you can get some washout. And you can see it's really thick here. You can see how there's a lot of extra tow and resin right here. Let's see if we can get a little bit of resin out of there. That looks pretty juiced up right there. Let's see how that lays down in there a little bit better. Do the same on this side. apologize for not being able to see the comments. Normally I'm on a program that allows me to do that. Right now I'm on the cell phone. I got my cell phone with a jumper charger battery on a gimbal. And that's pretty much what you want right there. You want it bunched up. Want a nice crown on it. And you want it away from the parting plane here. And then the last thing I do before I close her up, I get a little resin on top of this. Now my air bubbles are really gone by now. They've all popped out of there. And I like to brush the resin right down that groove right here on the edge. I try to keep this fairly thin. It's just almost like another surface coat. Now, this wet layup, the people that are watching this, you're thinking, man, there's a lot of extra weight in there, and there is. Basically, if you do this in a hydraulic press with pre-preg or a bag or whatever, you'd be able to get a lot better part and lighter. But I'll tell you what, for a garage shop operation, when you just want something that works really well, you can't beat this process here. It might be a couple grams or whatever, but overall, this is a really good way of doing it. You still get plenty of carbon. You're not aerospace quality or race team quality, but it's going to be plenty good enough. One of the things I've seen on other people's gears, I don't even know who they were, that they brought to me, and I had to repair them. They were for an RC plane. But this joint right up here, this is where it takes all the stress, all transferred from the axle all the way up to here. And they were delaminating. They had some core material, and they had carbon cloth, and then I don't know, maybe a little bit of tow, but they didn't have enough material up here, and they were delaminating. So this process here with that much tow, it's almost a sure thing you're going to get a good gear out of it. Now these molds are marked, you know, you see the lines on them. I got them marked. So I get the alignment right. Now I'm getting a lot of squeeze out here at the top. I might have too much in here, but that's all right. I'll clamp it and I'll let it wash out. So it's going to take 4 or 5 clamps. I'm going to put one in the middle, right smack dab over the top, and then I'll come out here, put another one. I'm going to need a pretty good squeeze out in the center. Now, mold's starting to go a little bit that way, so we'll make a mental note of that, so we'll make sure we get clamps here. So when you start closing these clamps, you're gonna have to eyeball this gap line right here, and you're gonna have to decide where to start squeezing at. So it's a little askew, so let's work it back this way with some clamps. And everything's floating around pretty good in there right now. You know, it's still moving quite a bit. Yeah, see, now it's coming back parallel. The more this thing bottoms out, the more uniform it'll become. Now as you clamp these clamps on the outside, you'll notice the ones in the center are getting loose. Come back over, put one here. Give me 1 second. I think my shop cat wants out. You want out, Cheeto? I think Cheeto wants out. I'll be right back. Come here, Cheeto. He goes in and out. If I keep letting him out, it cuts down on my litter. As you probably have already noticed, this is a very clean process here. Yeah. Now normally I don't put this many clamps on a landing gear mold. I just saw it go askew a little bit and I thought, you know what, I'm just going to go ahead and put a couple extras on it. Normally I can get away with just 4. Okay, now it's obvious that we still need to clamp the outside. So we're going to flip it over, and what I'm going to do there is I'm going to put some plates on there. I'll probably have to trim that. And then I think I'm going to put some carbon fiber cloth out there for a little extra split resistance. Man, that sucker's heavy now. That's a lot of weight on there. So, let me see here. Let me get this thing where I can adjust this thing where you can see what I'm doing. See, it's not too bad, but it's got a few extra long ones on it. Trim that down a little bit. That's when you know you're getting a good haircut, when they come back and sort of tweak a little bit. You just want it to go inside that mold. You don't want anything hanging out. That'll be good. And I think, like I said, I'm going to add a little carbon cloth to that. I got it laying right there. So I'm going to wet this cloth out. I'm going to get a lot of squeeze out on this. Yeah, it looks good. Get rid of the Rice Krispies in there. That cloth on there. That's just a little extra thing, you know. And I'm going to do the same to the other side. Go over here and probably trim this side up. No, that side's okay. Well, like they usually say through the video, if you like, subscribe, and share. You know, we're all out here putting these videos out for fame and fortune, you know. Yeah, posterity. Had to laugh. I did a video on Sparky's channel, and I don't know, it was a week or two later. I said, well, did I make you any money? He gets on his whatever, you know, his stats. He said, yeah, we're up to 98 cents on that one video. I said, good deal. But if you get enough videos, here's the thing though, you make these videos and they sit there and people can only consume so much of it. So it becomes really imperative that the algorithm through these, whatever your social media thing is they put it in front of people. You know, there's so much information out there. It's like the old, you know, thing where the train's going down the track collecting information. They've got all this new information coming on board and the latest and greatest. And then there's a guy at the caboose. He's throwing off extra information that we've had that's still good because there's no room for the new stuff. It's sort of funny. But as long as somebody gets something out of it. Now the next step, obviously, is get these end plates on here and then clamp it from this direction. And by now, after I get those clamps, it ought to be up to about 80-pound mold. Now, I think I remember putting some release agent on these things. Okay. Let me stick these on there. Hopefully they'll stick long enough where I can position the clamp. This one obviously is not going in my oven. This one's got to go into the hot box. And then of course I'll be careful when I tighten this down that it's in the right position. It'll slide around a little bit. Let me grab a clamp real quick. Gotta get a long one for this. Tilt it sideways to support it. Now it's going to get gooey until you get a good clamp on it. It's like when you put glue on a woodworking joint. when you start to clamp it, it starts to hydroplane on you. It starts to move around, it's all slimy. You keep an eye on it, and eventually you get a bite on it. So yeah, that's how to lay up one of these gear. Could have gone faster if I had a recipe to go in it. But I'm not worried about that today. We'll make it work. I just wanted to get it laid up. I spent all the time on the surface coat. Go through here and tighten these up. Clear some room on the floor here. Go. I got it this many clamps. Basically, I'm just finger tightening. Now, let me clean some mess off the bench here. Best way to clean this is scrape it with some acetone. Paper towel and just do the scrape. Now if I was doing a bunch of these things, I would have probably laid down more paper. I used to take newspaper, of course, when they had it, and I'd lay down a whole stack of it, and I just keep peeling off the layers as I expose the clean layers. Acetone, it cleans up real quick. Well, I think that's pretty much all I wanted to cover, really. Maybe since I've got this video up, I'd like to come back and tomorrow and do maybe a 10 or 15 minute, maybe 20, and I'll open up these molds and we'll see what we got. See if we got anything worth using. If you get something bad, at least you got an education out of it, right? But here's the thing, if you open that mold on that landing gear, and let's say there's an air bubble or something on it, and it's really not structurally compromised, what I normally do is I just fix it and then give it away. You know, tell the person, hey, here's a free one. It's got a little patch on it. All you got to do is take it home, put some primer and paint it. It's good to go. But I try not to waste parts, you know. Obviously, if you get something out of the mold and it's not safe or it's not structurally sound, you get rid of it. But I'll tell you another thing I've done. If you get it, let's say you get a landing gear out of the mold and it's bad. It's like one of the first ones you make. So the thing is all messed up. It's got a big void in it, right? You're trying to figure out the ingredients and how much carbon. So what you do, you throw it aside. Lo and behold, a couple months later, you think, you know, I need to make this landing gear mold for a new gear, but I need it a little bit more refined. I need to do a carbon gear that's thinner. So what you do, you take that old gear, it wasn't any good, and then you patch it up, you putty it, you do whatever you got to do to it, and then you whittle it down to where it's really thin. And then you make a mold off of it. So you use it as a plug. See what happens. Yeah. That's like the Wicked Witch of the West. Look at that. She just melted away. So that's how fast that's how fast styrofoam disappears. So if you'd ever want to do a mold, you lay glass on the outside of it. You glass it all up, make it all pretty, and you got to get rid of the styrofoam in the center. You saw how quick it goes away. It goes away as quick as cotton candy in a pot of boiling water. That's why, that's one of the reasons why composite work in this acetone bottle shouldn't be anywhere close to foam wings. You'd splash one little drop on your foam wing and melt a 2-inch hole in it. So, yeah. And that's another reason I got 2 benches here, one composites and one for other stuff. But so, how many watchers we got? We got 8 right now and 14 thumbs up. That's pretty good. 2 hours and 23 minutes. Holy cow. Oh, had fun doing it. Hope you guys had fun watching it. You can always fast forward through it. Throw a like and a subscribe up here. And send it off to somebody. If you know somebody that's into this composite stuff, you might not be. Just send them the link. But yeah, that's all I got. We'll open up these molds here in a day or two, and we'll see what we got. So thanks for coming by. I enjoyed doing it, and like they say, fair winds, tight lines, and I'll talk to you later.